Hello Year 12, welcome to a revision video of topic 2, the network concepts, and this one is dealing with question 9 from the chapter review, and so let's get into it. This is a diagram, shows a network of walking tracks in a small national park. These tracks connect the campsites to each other, so each vertice is a campsite, and the park office in the middle there. The lengths of the tracks in metres. Okay. So I've got to find a few things. Arrange a campsite C8. Plans to visit campsite C1, 2, 3, 4 and 5 on her way back to the park office, the shortest distance. So you've got to visit C1, 2, 3, 4 and 5 before getting back to there. The shortest distance, well, if you've got to go that way, yep, it's only C8 to C1 is 160. Then can do that way, but it looks like a little bit of backtracking. C1 to C2 then is 120. C2 to C3 is 130. C3 to C4 is 110. C4 to 5 is 80. And then 5 to the office what is that, 150. 150. I'm not going to redo that last bit to make it a bit neater. 150 there. C5 to office. And what do we end up with? 13, 14, 17, 19 and 6 is 25. 3, 4, 5, 6, 7. 750 metres is the shortest distance. Each day the ranger on duty has to inspect each of the tracks to make sure they are all passable so they can be walked on and you can get through. Is it possible for her to do this starting and finishing at the park office without retracing her steps? Explain why or why not. So in other words, you've got to cover every edge, every path, without retracing her steps. In other words, no repeated paths or edges. And that to me sounds like an Eulerian circuit. Every edge once, exactly once, and end up where you started. That's an Eulerian circuit. That one, we've got certain conditions. Each of the tracks starting and finishing at the same place without retracing. 3 conditions. Now I'll just learn how to spell this. E-U-L-E-R, Eulerian circuit. Every edge once, starting and finishing the same place, and that exists if every vertice of the graph has an even degree. So every vertice must be even for that to happen. Let's go with park office first. That's a degree of 2. C1 has 4. C2 has 2, 4. C3 has 2. C4 has 1, 2, 3, 4. C5 has 1, 2, 3, 4. C6 has 2. Where's C7? That has 2. And C8 has 1, 2, 3, 4. So yes, it is possible because these conditions require an Eulerian circuit, and an Eulerian circuit requires every vertice even degree. Okay. Following a track inspection after wet weather, the head ranger decides it is necessary to put gravel on some walking tracks to make them weatherproof. What is the minimum length of track? So there's a key word, minimum. They will need to ensure that all campsites and the park office are accessible along the gravel track. Well, there's our clues to create a minimum spanning tree, which conditions are you've got to have every vertice, in other words, every campsite and the park office. Every vertice connected. They must not have any repeated or loops. Okay. Righto, let's do this. We'll do in order, C1, so we're going to make sure that every C7, C8, and the office. Okay. Now it says it doesn't matter where we start, so let's start with the office. And the office, we've got to find the least distance, and that's office to C1 is 140. The office to C1, 140. So C1 and the office are covered. Okay, now from C1 and the office, we've got office is 150, that's the only one left there. From C1 we've got 3 left, 230, 120, 160. Well, the 121 is the shortest one, C1 to C2. Just do that one. C1 to C2, 120, 120, C2's covered. Okay, from all of those, we have 150 there, 160, 130. Looks like it's the least weight. 150, 160, yep, C2 to C3. 130. C3 covered. Let's do that in there. And now we've got to go check all the weights, see which is the least one again from all of those 4. We've got a 150, 160, 230, 200, 400, 110. 110 looks like it's a go, C3 to C4. 110. C4 is covered. Okay. And going by the looks of the weights, the C4 to C5 is the least distance of all of those. 150 off the park office, 160, 230, 400. Yep, C4 to C5 is 80. So C5 is covered. Still no cycles, loops, repeated edges, that's good. So now we've got to get to 6, 7 and 8. Well, there's 7, 6 and 8. Okay. So now going by the least weight of all of those, we've got 150 from C5 to the office, but that creates a cycle, so that's out. We've got 280, 350, might be this one, 160. I'd say the C1 to C8 is the next one. That's only 150, 160. C8, C8, 160. No cycle created at this point, and C8 is covered. So now we've got to get to C6 and C7. C6 here and C7 there. Okay, just going to move this up a little bit. Gives a bit of space. Alright, going all the edges unused, the least weight. Getting to C6 and 7. We've got a 350, 250, 280, 600, 400. I think the 250 one is the least. C8 to C7, 250. C8 to C7, 250. That leaves C6. To get to C6, we can either, well, the only way really is from C5 at 280. That's the least. C5, C6, 280. That's the only one left. C6. So now we just add these up. So we got 140 plus 990. Did I miss one? I don't think that's the answer. $280. Yep, plus 280. That's the answer. I forgot that one. 1270 meters. So 1270 meters will cover every campsite connected with the minimum distance. Yep, there we go. Done. Thank you.